given that relative viscosity is equal to neta relative is equal to 1.2 1.1 and concentration C is equal to 1%. You know that inherent viscosity is equal to neta inherent is equal to ln relative viscosity का whole divided by concentration. So inherent viscosity is equal to ln 1.1 divided by 1 is equal to 0.0953 deciliter per gram. Answer. Cement polymer L naught is equal to 100 mm and change in length given by delta L is equal to 0.03 mm and initial temperature T1 is equal to minus 30 degrees centigrade and final temperature T2 is equal to plus 30 degrees centigrade. The relationship between the thermal expansion and temperature is given by delta L is equal to L naught into alpha into delta T, where alpha is equal to coefficient of thermal expansion. So alpha is equal to delta L divided by L naught into delta T. Putting the above value, delta L is equal to 0.03 divided by 100 into change in temperature. Delta T is equal to T2 minus T1, then 30 minus 30 is equal to plus 60 degrees centigrade. Then 60 is equal to 5 into 10 power minus 6 per degree centigrade. Polymer composite having cross-sectional area A is equal to 40 into 40 mm square and the thickness of the polymer composite T thickness is equal to 5 mm. Then converted into meter, 5 into 10 power minus 3 meter, and this 40 गुणे 40 into 10 power minus 6 meter square. And heat flow rate Q dot is equal to 60 watt and change in temperature is equal to 90 minus 25 is equal to 65 Kelvin. The thermal conductivity of the polymer given by K is denoted by the thermal conductivity. So the thermal conductivity of the polymer is given by heat flow rate into thickness of polymer divided by cross sectional area of polymer into change in temperature. Then the put all the value. The heat flow rate given equal 60. Thickness of polymer sample given by 5 into 10 power minus 3 meter divided by cross sectional area 40 into 40 गुणे 10 power minus 6 into change in temperature 65 Kelvin. Then thermal conductivity is equal to 2.88 watt per meter Kelvin. That extruder power supply in extruder P is equal to 40 kilowatt, and mass flow rate m dot is equal to 240 kg per hour. Then this unit change into the kg per second. Then mass rate is equal to 240 divided by 3600 kg per second, चूँकि 1 hour is equal to 3600 second. So mass rate is equal to 1/15 kg per second. Now, given that specific heat capacity Cp is equal to 4 kilojoule per kg Kelvin. Simply ask change in temperature. Then the power is, you know that power is equal to mass rate into Cp into change in temperature. So change in temperature is equal to power divided by mass rate into Cp. Then power given by 40 kilowatt divided by mass rate is equal to 1/15 into Cp given by 4 into 10 power 3. is equal to 150 Kelvin. The graph given that monomer their functionality, mole and equivalent into functionality गुणे mole. First mole is pentaerythritol. Functionality is equal to 4, mole is equal to 1.5, then equivalent is equal to 4 into 1.5 is equal to 6. And second is tricarboxylic acid, which functionality is equal to 3, mole is equal to 1, and so their equivalent is equal to 3 into 1 is equal to 3. When using the Carruthers equation, when you know that the Carruthers equation, then the number average degree of polymerization is equal to 1 upon R divided by 1 plus R minus 2 Rp. This equation valid only if the functionality of the both monomer have equal. If the functionality of the both monomer are not equal, then this equation are not valid. In the given question, you can see that the functionality of the pentatritol is 4 and the functionality of the tricarboxylic acid is 3. The functionality of the both monomer are not same, so these equations are not applied. So you use the average functionality concept. Then the degree then the average functionality is equal to 2 गुणे limiting equivalent divided by total moles. The average functionality is equal to the average functionality is equal to 2 गुणे limiting equivalent for the pentathiol equivalent is equal to 6 and tricarboxylic acid for the tricarboxylic acid equivalent is equal to 3. So the limiting equivalent is equal to 3. So 3 divided by total mole 1.5 plus 1 is when equal to 2.4. Then average functionality is equal to 2.4. Now the action is equal to 2 divided by 2 minus average functionality into P, where P is equal to extent of reaction. So in question number 19, given that action goes to infinity, so this quantity goes to 0. Then P is equal to 2 minus P average into P is equal to 0. So P is equal to 2 divided by average functionality. So P is equal to 2 divided by 2.4 is equal to 0.833. This is a fractional. The fraction extent of reaction. So the extent of reaction in percentage is equal to 83.3%. Given that extent of the reaction P is equal to 80%, so the extent of reaction in the fraction is equal to 0.8. Now you use the degree of polymerization is given by 2 divided by 2 minus P into average functionality. Then 2 divided by 2 into 2 divided by 2 minus P 0.8 into 2.4. Then number of degree of polymerization is equal to 25. After calculation you get 25. Unit 1 spring and 2 dashpot are connected in the series. That means let's 1 spring and 2 dashpot connected in series. His modulus is equal to G neta 1 neta 2 and applied state sigma, shear stress sigma. So spring and dashpot are connected in the spring, so sigma 1 is shear state in spring is equal to shear state in dashpot 1 is equal to shear state in dashpot 2. So sigma 1 is equal to sigma 2 is equal to sigma 3 is equal to sigma for spring sigma 1 is equal to sigma is equal to G into gamma 1. Gamma 1 strain produced in the spring and gamma 2 is equal to strain produced in the dashpot 1 and gamma 3 is equal to strain produced in the dashpot 2. And for dashpot sigma 2 is equal to neta into shear rate 1, shear rate 2, and sigma 3 is equal to neta t into shear rate 3. Equation number 1. But the total shear strain produced in the mechanical model is equal to gamma is equal to gamma 1 plus gamma 2 plus gamma 3. Differentiate this is equation with respect to t. Then you get shear rate is equal to shear rate 1 plus shear rate 2 plus shear rate 3. This is equation number 4. In equation 4, put the value from the equation 3. Gamma 1 is equal to sigma 1 upon g plus shear rate, and gamma sigma 2 divided by neta 1 plus sigma 3 divided by neta 2. चूँकि sigma 1 is equal to sigma 2 is equal to sigma 3, so shear rate is equal to sigma rate divided by g plus 1 upon neta 1 plus 1 upon neta 2 into sigma. Question number 21. This is the answer of the question number 21. Simply given that in question number 22 given that sigma is equal to sigma naught into e की power I iota t. Put these values in the given equation. In above equation, then shear rate is equal to d upon dt sigma naught iota omega t divided by g plus 1 upon neta 1 plus 1 upon neta 2 into sigma naught into e power iota omega t. Integrate this with respect to the time, then you get gamma is equal to gamma naught e की power I omega t divided by g plus 1 upon neta 1 plus 1 upon neta 2 into 1 upon iota omega into sigma naught into e की power iota omega. This equation is converted into gamma is equal to sigma naught divided by 1 upon g plus 1 upon I omega t 1 upon neta 1 plus 1 upon neta 2 into e की power iota omega t. चूँकि you know that 1 upon iota is equal to minus iota, so gamma is equal to sigma naught into 1 upon g plus 1 upon g minus 1 upon iota upon omega into 1 upon neta 1 plus 1 upon neta 2 का होल डिवाइड e की पावर ओमेगा t. Then simply check option number B. Correct. 17 to 80. The given that termination done by the bimolecular method, no chain transfer. That means what is the bimolecular termination? The bimolecular termination bimolecular termination has the two methods. One is by coupling and second by the disproportion. In the coupling, two active polymer either combine to each other form the polymer like a monomer N. Termination by coupling. Then in this polymer, both active centers either combine to each other and form the polymer. Then R M M plus N R. This M is the donate as the monomer repeat unit of monomer, and this is the number of the repeat unit, and this is also donate the number of repeat unit. So this is a simple concept of the termination done by coupling. But in case of termination done by disproportionation, active monomer, in this case the hydrogen atom transfer, in this method the hydrogen atom of this place is transferred to the air and form the dead polymer. Then R M plus R Mn. So simply say that the termination done in a termination done by the coupling, the two initiator per fragment are added in the monomer. But in case of termination done by the disproportionation, only one free radical are attached to the monomer unit. Now coming on the question number 17. Let total number of coming on the question number 17. Let total number of chain in polymer sample is equal to N naught and fraction of chain containing two initiator per fragment is equal to A, and fraction of chain containing one initiator fragment is equal to 1 minus A. So the total fragment is equal to in this case the two initiator containing two initiator, so 2 into A plus in this termination done by the disproportionation only one free radical are contained, then 1 into 1 minus A into N naught. So N naught into A plus 1. Now in question given that the total number of fragment per initiator is equal to an average of the 1.6 initiator fragment per molecule chain is equal to per month. Given that average fragment per molecule polymer chain is equal to average, then this is N naught into A plus 1 divided by N naught is equal to 1.6, then is equal to, after solving it you get A is equal to 0.6. Now you get A is equal to 0.6. This is the fraction part of the polymer chain containing two initiator. Then in question number 17 ask the percentage of the final polymer chain containing one fragment. For the one fragment, then is equal to 1 minus 0.6 is equal to 0. So though in question number 17 percentage, then in final polymer the percentage of final polymer containing one initiator fragment per chain is equal to 1 minus A into 100, then is equal to 1 minus 0.6 into 100 is equal to 40%. Then in question number 17 option number A correct. In question number 18, given that termination done by coupling, the percentage termination done by coupling, then the in coupling 2 into A into N naught divided by total number of the fragment N naught into 1 plus A into 100. Then the put the value of A and 2 into 0.6 divided by 1.6 into 100. Then you get 75%. Then answer is question number